Hello and welcome back everyone. This is Noah, and in this video we're going to walk through solving rational equations symbolically. Alright, so very simple instructions for this set of examples. We're given a group of equations, all of them dealing with rational expressions in some way or another, and we want to solve all of these symbolically. The first one that we are given, part A, is x over x plus 3 equals 4, and we want to be able to isolate x. Now this is interesting because there's an x in two different locations. How can we get just a single x out of this? And that's one thing that we're going to have to address and approach as we tackle this problem. The other thing that we want to recognize is that it has a variable in the denominator. And if we have a variable in the denominator, then we can't solve the equation with the variable in the denominator. We're not looking for a 1 over x equals a number. We're trying to get x over 1, or just x equals some number. So we need to get it out of the denominator. And our technique for dealing with that first is going to be to multiply. Let me rewrite this. I've got room on both sides here. Multiply by the common denominator, multiply both sides by the common denominator to clear out all denominators. If we multiply the left side by that x plus 3, it cancels with that denominator, and so we no longer have that denominator. And when we bring this down, we'll just have an x left on the left side. On the right side, we can distribute the 4 across. We'll get 4x plus 12. And now we still have two instances of x, like I was saying before, but now we actually are in a familiar situation. We can get those x's on the same side. We can subtract the 4x from both sides, and then we'll get minus 3x equals 12. And then we're going to divide by negative 3 on both sides to cancel the negative 3's so that we are left with x on the left and a negative 4 on the right. Now, this wasn't really talked about in the intro video, but I did mention something about the domain changing when we canceled this, right? So all of a sudden, in our original, we want to note that the x could not equal negative 3, and after we cancel, it could have equaled negative 3. Now, that doesn't occur here. We just get x equals negative 4. But we need to think about this and note that x cannot equal negative 3 in the original equation. Right? If this would have been a negative 3, that wouldn't have actually worked, and we could have potentially done that. And I think we're going to see that in one of the next problems coming up here. But for us, we're done here. We've got x, it's negative 4. We can check if we want, and I'll do that just for posterity's sake at this point, so you guys can really see that this worked. We have negative 4 over negative 4 plus 3 equals 4. That's what we're asking. Does that work? Negative 4 on top stays. Negative 4 plus 3 is negative 1. You want to know, does that equal 4? And sure it does. Negative 4 divided by negative 1 is a positive 4. So yes, negative 4 is a solution. When we plug it in, we do get a true statement there. So we can write the solution set is the set containing just the number negative 4. That's the only solution that we got here. All right, so there's our intro to this. That's the basic idea. We're going to run into some complications as we go. So let's take a look at this next one, see what additional things we might need to be considering and paying attention to. So let's see. Let's go ahead. Well, let me just read this off. We have x over 5x minus 30 minus 2 over x minus 6. And so I want to find the common denominator here. For this first fraction, I'm going to factor it first, so we may need to factor the denominators. And this is just part of the process to find that common denominator, right? We want to multiply both sides by it, so we need to know what it is. So 5 times x minus 6 here minus 2 over x minus 6 equals 1. Move this a little bit. And now we can do what it says in red there, multiply both sides by the common denominator. And that common denominator is 5 times x minus 6, right? It's the 5 and the x minus 6. We don't need to do the x minus 6 twice. That's a common mistake, so watch out for that. If you multiply by x minus 6 twice, you can get to the answer, but it's going to make it way tougher. If I just do a single x minus 6, when I distribute the 5 times x minus 6 to both fractions, it will cancel in both of them, so we will remove that denominator there. All right, so let's do this in a couple of steps. 5 times x minus 6 times the first fraction, x over x times, 5 times x minus 6 minus, and then that 5 times x minus 6 distributes to the second fraction, 2 over x minus 6, and then equals, bringing down that equal sign there. On the right side, we will have just 5 times x minus 6 after multiplying it by the 1. And we'll distribute that 5 across in the next step. Now let's go ahead and do some cancellation. We have 5 times x minus 6 can cancel top and bottom in the first fraction, leaving us with just an x here. In the second fraction, the x minus 6's can cancel, leaving us with minus 5 times 2. Now we'll bring down that equal sign, and on the right side we'll multiply the 5 across 5x minus 30. Great. Now we have a nice linear equation that we can solve out. So we have x minus 10 equals 5x minus 30. I'm going to go ahead and subtract the x from both sides and add 30 to both sides. This will get the x's on the right side. 5x minus x is 4x. Adding 30 to both sides clears it off the right side, and we get 20 total on the left. We can now divide by 4 and get 20 divided by 4 is 5. So 5 equals x. Now, real quick, we want to check this in the original. The domain of the original for both of these is that x cannot equal 6. The number we got is not a 6, so we are totally good here. We can say now that the solution set is the set containing just the number 5. I'm not going to continue doing checks, but we could check that, and it will work out just fine. Let's go ahead and move on to part C, bottom left of this worksheet. We have negative 7r plus 4 over r minus 4 equals minus 7r over r minus 8. So there's no factoring to be done here in any part of this problem. If I look at the top left, nothing can factor out there. The bottom left and the bottom right, nothing can factor out of those. And 7r is just a single term, so there's no factoring in that either. So we will skip ahead straight to the multiply both sides by the common denominator, which is an r minus 4 and an r minus 8. We need both of them there, the r minus 4 and the r minus 8. But we need to do this to both sides. So r minus 4, r minus 8 on the left as well. This one's nice. There's no addition of rational expression, so I don't need to do any distribution. I can start canceling straight away. On the left, the r minus 4s can cancel. On the right, the r minus 8s can cancel. Now on the left, we're going to be left with r minus 8 times that entire numerator in parentheses. Don't forget these parentheses right here. Negative 7r plus 4 in parentheses equals, bring that down. We have a minus 7r left from inside that fraction, that rational expression we had. And then we have the r minus 4 left after the r minus 8s cancel. Great. So we are well on our way here. Looks like we're going to have to do some foiling. I need to take this r minus 8 and FOIL it with the minus 7r plus 4 on the left. So we'll get a minus 7r squared. And then we'll get a plus 4r. And then we'll get a plus 56. 7 times 8 is 56r from the inside terms. And then the last terms will get a minus 32. 8 times 4 is 32. On the right side, we'll say that this equals negative 7r squared plus 28. After distributing that minus 7r, the minus 7r times r is minus 7r squared. Minus 7r times negative 4 is a positive 28. Oh, and I missed the r. I knew that my brain was missing something there. Cool. All right, so right away, when I look at this, I note that that minus 7r squared on both sides is the same. If I added it to both sides, they would just cancel out. So I'm going to do that first, and then I'll combine like terms on the left. I'll get 60r minus 32 equals 28r. I can subtract 60r from both sides, which will isolate the number negative 32 on the left. And then on the right, 28 minus 60 is a negative 32. And we've got that r still there as we combine those like terms. So we'll divide by negative 32 on the right. We'll divide by negative 32 on the left, leaving us with 1 equals r. And you guys notice that we always want to double check, can we plug this into the original? Right, and if we look at the r minus 4, no problems there. The r minus 8, no problems there. So this will work, and we will conclude that the solution set is the set containing the number 1. All right, one more example here for this video. We have part D, where we have 8 over x plus 6 minus 9 over x plus 9 equals negative 9 over x squared plus 15x plus 54. We want to start by factoring the denominator of the right side, x squared plus 15x plus 54, so that we can see what factors we have and work out what the common denominator is for this. So I'll bring down the 8 over x plus 6 minus 9 over x plus 9. Bring down our equal signs, bring down the negative, put the 9 on top, and then in the denominator we want two factors, x in the first positions to get the x squared, and then we need plus 15x and plus 54. So 54, I'll look at the factor pairs 1 and 54, 2 and 27, and I'm looking to see, is anything going to add up to 15? 3, I believe, goes into this 18 times, and that almost looks good, but we don't want differences because this is a positive 54. So we're going to keep going. 4 doesn't go in, 5 doesn't go in, but 6 does. We double 3, we get 6, and if we half 18, we get 9, and those do add up to 15. So we want to use a 6 and a 9, which multiply to be 54 and add to be 15. And, you know, that's really best case scenario here, right? We wanted an x plus 6 and an x plus 9 to match the fractions we already had, so that we don't have a bunch of factors that we need to multiply both sides by. So that was really nice that that worked out in that way. Oops, a little glitch there. Sorry about that. Okay, so we'll go ahead now and multiply both sides. by that common denominator x plus 6 times x plus 9. Do that on the left as well, x plus 6 times x plus 9. And then on this left side, we're going to distribute this to both terms before and after that minus sign. So we'll have x plus 6 times x plus 9 times 8 over x plus 6 minus x plus 6 times x plus 9 times 9 over x plus 9. Minus is there. Now we're to the equal sign. On the right side, we can cancel right away. There's no distribution to be done. The x plus 6's can cancel, and the x plus 9's can cancel. So we're just left with a minus 9 on the right side. All right, this is going to work out pretty nice, I think. I think here we can cancel the x plus 6's in the first fraction, and then in the second term, in the first term, we can cancel the x plus 6's and be left with x plus 9 times 8, and then minus, and then in the second term here, the x plus 9's cancel, and we'll be left with the x plus 6 times 9, bring down the equals negative 9 now. All right, we'll go ahead and distribute the 8 across this first set of parentheses, the x plus 9, to get 8x plus 72. Bring down the minus. And I want to be careful here. This minus needs to distribute across, as does this 9. So we're going to get minus 9x and then a minus 54. 9 times 6 is 54, but the minus goes across with it to make a minus 54 there. We'll bring down the equals negative 9. All right, I'll combine like terms on the left. I've got negative x and then 72 minus 54. Let's just make sure we've got that all hashed out. Bring a 1 over. 12 minus 4 is 8. And then 6 minus 5 is 1. That's 18. So this is plus 18 equals negative 9. We'll subtract the 18 from both sides. And we'll get negative x equals negative 27. We can divide by negative 1 then on both sides and be left with x equals 27. Once again, we're going to check and just make sure that this works in the original. The only numbers that wouldn't work are negative 6 or negative 9. And 27 is neither of those, so it doesn't look like any of the examples in this video actually ran into that problem, but it very much can. Be watching out for it. It is really important. If that number does match it, it's not actually a solution. So here 27 is, and we can conclude with the solution set is the set containing the number 27. All right. That is it. We have run into pretty much all the techniques that we need to see in these problems. Go ahead and give the Now You Try problems a go, and we'll run through the solutions to those in the next video. Thanks. See you soon.